Remember that at the end of every chapter, our textbook has an algebra skills review. So at the end of chapter 3, we have a review of algebra, and it is concentrating on the slopes of parallel and perpendicular lines. If the slopes of two or more distinct lines are equal, are the lines parallel? To find out, try drawing on graph paper two lines that have the same slope triangle. So remember that slope is rise over run. So if I want to go from a left point to a right point on the line, I rise up 3, so that's my slope, a rise of 3 over a run of 1, 2, 3, 4. Okay, then I look at this one. Its slope is a rise of 3 and a run of 4. So they have the same slope, and you can see that the lines are parallel. So this is a conjecture, and the conjecture on your conjecture list follows conjecture number 16. It is not numbered. It just says algebra skills number 3. Slopes of parallel lines. In a coordinate plane, two distinct lines are parallel if and only if their slopes are equal, or if they are both vertical lines. Now, this if and only if means I can go either way. If lines are parallel, then their slopes are equal. And I can also say, if two lines have slopes that are equal, then the lines are parallel. So that's what the if and only if means. You can go backwards and forwards with this. The reason that they say or if they are vertical lines is because, remember, vertical lines have an undefined slope. So their slope would be some number over 0. So that's why they're not saying that these lines would have a slope. So that's why they kind of add that in there. If two lines are perpendicular, their slope triangles have a different relationship. It says study the slopes of the two perpendicular lines at the right. So this first line over here has a slope of negative 4 over 3. Now, how can I figure that out? I can start, let's see if I can find a good point here, right here, okay? I go rise or fall of negative 4 down, so that's negative 4, and then to the right 3. So its slope is a negative 4/3. This line here is perpendicular to it, and look what its slope is. To get from a left point to a right point, I'd have to rise up 3 and run 4, 3/4. So the lines are perpendicular, and look at their slopes. 4/3 flips to be 3/4. The fancy name for that is that they are reciprocals, flips of each other, and they also have opposite signs. This one here is a negative, and this one here is a positive. So this is another of the conjectures that is at algebra skills number 3, following conjecture 16 on the list. It says, in a coordinate plane, two non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals of each other. So now, let's talk about this vertical. If this line is a vertical line here, its slope is undefined. So that means there's some number on the top. You go up and down some number, but you go left and right 0. Perpendicular to that would be a horizontal line. And is that the opposite reciprocal? Well, sure. Take number over 0 and flip it to be 0 over a number. So that means you go up and down 0 to get from a point here and a point here to a point there on a horizontal line. So I go up and down 0 and then over some number. So undefined and 0 slopes also indicate that the lines are perpendicular to each other, vertical lines and horizontal lines. Okay, here's an example, a nice easy one. Consider A, B, C, and D have those coordinates. Are A, B, and C, D parallel, perpendicular, or neither? So it says, first, I'm going to calculate the slope of each line. So the slope of AB that's right here and here, would be y sub 2 minus y sub 1, 8 minus negative 6, over x sub 2 minus x sub 1, 6 minus a negative 15. So the top is going to be a 14, and the bottom is going to be a 21. And when I divide by 7 and divide by 7, it turns out to have a slope of 2/3. Okay, then they find the slope of CD. So for CD, 10 minus negative 2, and then the x's on the bottom, negative 4 minus 4. So the top is going to be a 12, and the bottom is going to be a negative 8. So when I divide by 4, I get a 3 on the top, and I divide by 4, I get a 2 on the bottom, and then that negative sign is there. So I look at the two slopes, 2/3 and its reciprocal 3/2, positive and negative. So they have opposite reciprocal slopes, so the two lines would be perpendicular to each other. So if this is a homework problem or a quiz problem or a test problem, this is how you would be expected to solve this. It's not just drawing a picture and saying, oh, I think they look like they're perpendicular. It has to be done with this algebra method. This is the second example. You're given 3 points, and you need to find the coordinates of a point P such that PQ, so wherever P is on this line, PQ is parallel to EF. So you want these two lines here to be parallel to each other. Okay, so this is what their solution is. We know that if they are parallel, then the slopes have to be equal to each other. So the slope of EF has to equal the slope of PQ. So over here, they find the slope of EF. So they take the 2 points, negative 4 minus 0, subtracting the y's, putting that on the top. And on the bottom, subtract the x's. So I have 5 minus negative 3. So it turns out to be a negative 4 over 8, which reduces to a negative 1/2. Then they say, okay, if this is Q, let's just draw any old P. So if I put it here, for instance, and just call its coordinates x, y. This line PQ has to have the same slope as EF, so its slope has to also be, has to be a negative 1/2, the same as EF. Okay, so now if I find out what the slope is of PQ, they did 2 minus y on the top for the y's and 4 minus x on the bottom. Okay, now they say, look at this. These have to be equal, and these have to be equal. They put the negative on the top. It could go either the top or the bottom. And so they solve each of these. They solve the bottom here and the top here. So 4 minus x has to be a 2, and 2 minus y has to be a negative 1. So if I subtract 4 from both sides here, I get negative x equals a negative 2, divide by a negative 1, and I get x is equal to 2. And here, subtract 2 from both sides. That gets rid of the 2 on the left and makes the right be a negative 3. To get rid of that negative sign, divide by a negative 1, I get a positive y and a positive 3. So therefore, one possibility is that P is at 2, 3. Now, another way you could do this, it says, how could you find another pair? Here's a hint. How many different ways can you express a negative 1/2? So you could say 2 minus y over 4 minus x is equal to a negative 2 over 4. You could say 2 minus y over 4 minus x is equal to a negative 3 over 6. Then you would set these equal to each other and these equal to each other to get a different p-value than you did originally. Set these tops equal to each other, set the bottoms equal to each other, solve each of those equations, and you're going to get even a third one. So you could keep doing this forever and ever and ever. There are an infinite amount of answers to this problem. So that is probably the hardest problem that you would have for your homework.